Okay, so in this video we're finding the vector curl of this function over here. So as you remember, for the first variable over here, to find this, we kind of start off with, we find the determinant of, we cover the first, so I have the standard definition set up here. We cover the first column, the first row, and then we focus on these four over here. Then for the second variable, we have a little T shape in the middle, like this, and then we focus on these two and these two, and for the last one, same thing, repeat. You cover this column, this row, and then we focus on these four. Now, so let's set this up. So essentially what we'll have is, we'll have, for now, something like this, and hold on, let me just fix my camera. So we'll have our partial derivative set up over here, and then this one over here, because remember we're focusing on these four because we're covering like this. Whoops, I got my pinky. Well, we're covering this and we're covering this, right? So we only have to deal with these four, and then we'll do the same thing over here, and x squared over here, and 3x z squared, because it's these four. I got confused there for a second. Okay, and now this one over here, negative 2xz. It's a little messed up, but that's fine. So now we expand this, and so we're gonna put the symbol right here. This is x hat, and the next one's gonna be minus. And the reason it's gonna be minus is because we're gonna have a t over here, like this. When we take the partial derivative of this right over here with respect to x, it's going to be a negative in the first. So we're going to put a negative over here, like this. So we're going to set this up. X with x squared, and then with respect to the partial derivative with respect to z of minus 2xz with respect to y. And the next one, because we cover this, so we have no negative function, remember, bottom, final column, first row, and we're dealing with these four over here. So there's no negatives here. We go back to putting a plus over here, right over here, whoops. And in this we'll have, partial derivative with respect to x, again, x squared, partial derivative with respect to y, and then 3x, 3x z squared. This time I got it right, didn't mess it up. And with the variable at the end, which is z hat. Now we got it set up. So now what we have to do is simply just cross multiply these two. Everything, just cross multiply and find out what we get. So the first cross multiplication we're going to have the partial derivative of this with respect to x, which will just be this is because this is first column, first row. So this is partial derivative of y, and then partial derivative of z at the end over here. There we go. Yeah, that's correct. Okay, so partial derivative with respect to y. Well, there's no y over here, so this is just going to be 0. So in the first, I'll just write f for function is equal to, and then we'll do the little brackets like this, and so the first point we'll have is 0, because the partial derivative of this with respect to y is 0. And the second one, with respect to z, we'll just have, so we'll have minus, and then we'll have, remember this is z squared, so we carry the z, we carry the 2, 6xz, and that's the first point. Now second point over here, this one, partial derivative of this function with respect to x, we get a negative, but there was already a negative. We have to account for this also. So this is negative 2z. So negative 2z, because we treat everything like a constant, even the variable. And next one over here, minus, with respect to z, this is 0, so we get nothing over here. And this is probably going to turn into, it is going to turn into a positive. And final point over here, with partial derivative of this with respect to x. So we get 3z squared. So 3z squared. And then partial derivative of this x squared with respect to y, which is again 0, so minus 0. And this is what we have right now. So to simplify this, we're just going to, this is equal to negative 6xz, negative 6xz plus, so we carry this in here, plus 2z, and over here again plus 3z squared. So we're left with f6x squared and then 2z and then 3z squared. Alright, this is what we have. The curl of this vector field is another vector field. Yeah, thanks for watching.